In this video, we're going to look at constructing a cumulative frequency chart and drawing a cumulative frequency graph. When we hear the words cumulative frequency, all we need to think is running total. What I'm going to do is now construct a chart. The chart is going to be group data, and I'm going to say that this is the length of worms. So I'm going to breed some worms, and we're going to have now the length of worms in millimeters. So let's set this up. So this is the length, and it's given in millimeters. So this is going to be grouped, and I'll take my first group from 0, so 0 to 10 millimeters. So any worm between 0 and 10 will go in this one right here. Then we'll have 10, this will be a strict inequality, and we will go to 20. We will take 20 and we will go now to 30. We will go from 30, we will go up now to 40. We'll do a couple more. Let's do 40, then we'll go to 50, and then finally we'll take 50 to 60. So if I'm breeding worms, and I'll say that the maximum, it will get no bigger than 60 millimeters in length, we could put them here. So for example, now in the first interval, we could have one that's 0.1, we could have 0.4, we could have 0.87, we could go up to 10. All of those will fall in the first category or the first class. What I'm now going to do is introduce a frequency column. So this is how many of each of these I've bred. Remember, this is group data. Any work that we do with this is going to be an estimate because we don't actually know the lengths of the specific worms in each of these. So they could all be here, or in the first one they might be 9.9, 9.83 and then 9.67, for example, if we only had 3. So any work we do will be an estimate. So let's go ahead. Let's say I have 5 of these. So I've got 5 that are going to be 10 or less. I'm going to have 12 now that are going to be between 10 and 20. Let's say I've got 7 between 20 and 30. I've got 13 between now 30 and 40. Let's say I've got 8 between 40 and 50. And then I've got 15 between 50 and 60. At this stage, I'm going to introduce another column. And this is going to be the cumulative frequency. This is the running total. So writing it just here, this is the cumulative frequency. Here I have 5. If I now think about the total number of worms that I've got less than or equal to 20 millimeters, well, it's 5 and 12. So I'm going to have 5 plus 12. If I think about now those that are going to be 30 or less, I've got 5 plus 12 plus the 7. So we can see that we're going to be building this up. I wouldn't write all of these out. All I'm going to do is simply write them as we go. So what we're going to have is 5. That is going to give me 17. I'm then going to add another 7. That is going to give me 24. Just writing in here 24 plus the 13. That is going to give me 37. I'm going to have now 37 plus the 8, which is 45. And then finally, we've got the 45 plus the 15, and that's going to give me 60. That tells me now that the sum of the frequency, so if I add all of my worms up, I've got 60 worms in total. Let's see what this means. This means I've got 5 that are 10 or less. This says I've got 17 that are 20 or less. This tells me I've got 24 that are 30 or less, 37 that are 40 or less, 45 that are 50 or less, and all of them are 60 or less. Just a quick point here, just because this is 60 and this is 60, that's just coincidence. Those values generally won't be the same. I've just taken these class intervals and I've got now a sum of 60. Running total, cumulative frequency is a running total. What we can now do is go ahead and draw a cumulative frequency graph. The cumulative frequency will always go on the y-axis or the vertical axis. So what I'm going to do is just go ahead now and draw the vertical axis. So if I do that, we'll come down here and we will have it just there. On the horizontal axis or the x-axis, we will have the length of the worms, or if you like, the class intervals. So what I'm going to write down here is that this is going to give me now the length. So this is the length in millimeters. And this is going to give me the cumulative frequency, the running total. So that is my cumulative frequency. If we look at this now, we can see the first class interval is from 0 to 10 millimeters. The second one 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. So what I'm going to do is put 0 just here. It won't always start at 0. This is going to be 10, 20, 30, we're going to have 40, we're going to have 50, and I think I can just squeeze 60 on. So these are the classes. So all of my worms less than 10 would fit here, those between 10 and 20 would fit here, and we can go ahead and start constructing this. The cumulative frequency, I can see now I need to go up to 60 on this one as well. So I'm going to write down that the cumulative frequency, we'll have 10, we'll have 20, we'll have 30, we'll have 40, we'll have 50 and 60. This now is my running total. What I'm going to do is start now at the origin or 0, 0, and we're going to mark on points. When we're plotting a cumulative frequency graph, we plot at the end of the interval. So at the end of the first interval, it's 10. My cumulative frequency is 5. So I'm going to locate 10 and 5. So that's my first point here. We're going to come up and round. If I now look at the end of this class, I need to put my cumulative frequency, my running total, or the number 20 or less is 17. So I locate 20 on the length, and then 17 looks to be about there. If I now look by the end of 30, we've got 24. So here's 30, and 24 looks to be about there. So that's what I'm going to have now for my cumulative frequency or running total. By the end of 40, I've got 37 observations. So by the end of 40, we got 37. 37 looks to be about there. Okay, next one, what we're going to have is at the end of 50, we've got 45. So let's put that just there. And that's going to be just here. And then at 60, we've got 60. And that is purely coincidence, but those two values are the same. In general, that won't be the case. At this stage, I could connect this up with a straight line between each point, but generally speaking, we're going to use a curve as it's more accurate. So if I did this with a straight line, we would have something looking like so. But what we generally do is a curve. The quality of my curve right now isn't going to be fantastic, as drawing on the tablet is quite hard. I will have a go and we'll see how we go. So ideally, a sweeping curve through each of these points will give our cumulative frequency curve. So let's go ahead and try now to put on the curve. So our curve will come around, and as stated, this isn't going to be massively accurate, but it will give us some idea of what's going on. So what we'll do, we'll come through, so we'll come up to here, so round, we'll come through this point here, so we'll come round through that one, but just there. It will look something, give or take, like this, coming through, and then through to that point, and then we'll come up like so. So that is my cumulative frequency curve. It's a running total. So I've labelled all of this up. I might want to label the graph if I was asked to do so, or alternatively, if it was already labelled, I would plot the points. What we're now going to do is look at some information from this table on the cumulative frequency curve. We can find an estimate for the median length of the worms from my cumulative frequency curve. I can see now that the cumulative frequency is 60. So what we would have then is the following. The median, and this is important that we have this, is going to be in general n over 2. When I say n over 2, that is the observation that we take it from. So if I want an estimate for the median, I'm going to take it off the 30th observation and then drop a line down, a perpendicular line, to read off an estimated median for the length. So what we're going to have in our case, so that is the general term, we're going to have 60 divided by 2. which gives me now the 30th observation, the 30th worm. So what I'm going to draw from here is a line. I'm going to draw the line across from the 30th observation and drop this down here. Remember, this is an estimate. It's only, again, group data, and it's only as accurate as we can make this on here. So what I'm going to write under here is that this is the median estimate. In later videos, what we're going to look at now is a box plot, and we can draw a box plot off the bottom of this. For now, we're going to focus on the median and the quartiles. So that tells me now that this point right here, the median, is going to be approximately 36. So what I'm going to do is just write this down. So I'm going to say that the median, so an estimate for the median is going to be equal to 36 millimeters. It isn't 30. That's a common misconception. Often students write that the median is the 30th. It's not. It's taken from the 30th value. What we're now going to do is look at the lower quartiles and the upper quartiles. The upper quartile is going to be 3/4 of n. It will be taken off that value. So if we look here, that will be now 3/4 of 60. So writing this down, so 3/4 of 60 is going to give me now the 45th person, or the 45th worm, I should say. So this is now the upper quartile. This tells me that 75% of the worms were less than the value that I read off just here. So that's 45. We go across, we drop down, and what we might see is something we expected. As we can see, it's bang on this point right here, which is going to give us the 50, and we saw that anyway. So with this one, we would say now this is the upper quartile. So the upper quartile tells me that 75% of the observations now were less than 50 millimeters. When I'm talking about observations, I'm talking about the worms. Right, let's go ahead and do the next one. So we want the next one, and that's the upper quartile. So that's the upper quartile. Don't want that. Let's grab that one. We want this one. So that's the upper quartile. The lower quartile, LQ, lower quartile, is going to be taken now off 1/4 n. So if we say 1/4 of 60, this will be taken off the 15th worm, or the 15th observation. So let's go ahead and do that. This tells me now that 25% of the worms were less than this value that we're going to find right now. So let's go ahead and do that. Let's find that. That's the 15th. And remember, this is an estimate, and we'll drop that down. I'm going to say that's approximately, give or take, 19. So let's go ahead and write these in. So we can write in that this is going to be now the lower quartile. You might see this as Q, and I'll just write this here, less likely at this level, Q1, Q2, and Q3. That's highly unlikely, lower quartile, upper quartile, and median at this particular level. So here are my estimates. So writing these in, we're going to write an estimate. So writing in the estimate. So estimate, now we would have on here the lower quartile. So lower quartile, I think that's going to be about 19 millimeters. So 19 millimeters. The upper quartile, which is going to give us now that value we saw, we knew that that was going to be 50 as we saw that from our table. And this now gives us 3 really important pieces of information about our data. The median is an average, and it looks at a central measure. What we're now going to look at is the interquartile range. The interquartile range tells us about the spread of the data. The interquartile range is the middle 50% of worms. So how we work that out is as follows. We say that the IQR, the interquartile range, is going to be equal to the upper quartile minus the lower quartile. If I look at that in my case, what I've got here is 50 minus 19. So 50 minus 19, that's going to give me 31 millimeters. This tells us about the spread. We don't have now a maximum and minimum value to go ahead and finalize a box plot, but we could go ahead and look at this as a box plot. The interquartile range gives us the middle 50% of these worms. It's better in terms of looking at the spread than the actual range, the full range, if we had a higher and a lower value, or a greatest value of the worm and a lowest value of the worm, because it doesn't have any crazy fluctuations. So for example, if I had a really tightly packed interquartile range and then I had some massively bizarre freak worm that was hugely different to all the others, either really long or really small, then that is going to make our data slightly less, the use of it won't be as great if we're going to rely on the range alone. And that's why we use, along with the median, the interquartile range. So the interquartile range looks at the spread of the data. What I'm just going to do at this stage is introduce the idea of a box plot. We're not going to spend an awful lot of time on this, but hopefully it will give you some rough idea. Let's just move this out of the way. So there are estimates. In a later video, we will look at drawing a box plot. What I'm going to say now is that the smallest worm, so let's write this in, the smallest was going to be equal now to, let's make this 5 millimeters. And let's say we were told that the largest or the longest was going to be equal to, let's say we had 58 millimeters. What I'm going to do is draw a box plot from this information below. So what I'll have, and this will be a rough sketch, is the following. We're going to have now our lowest value. So our smallest value is going to be 5, which is going to be there. What I'm now going to have is the lower quartile, which is going to be just here. I'm going to have the median value, which is going to be just here. I'm going to have the upper quartile, which is going to be here. And then my greatest value is going to be roughly, give or take, here. What we would do is connect this up. That is my box just here. And then we would go ahead and connect these lines. So this is the box plot, and that is what it's going to look like. Just labeling these up, we have the lowest value. So this now is the lowest value. We have the lower quartile just here. We have the median just here. We have the upper quartile just here, and we have the highest or the largest value. I'll put it here. In fact, I'll change this to S, the smallest value, and then the largest value. So we could put these on. This is going to be the 5. We saw that an estimate was going to be 19. We saw that the median is 36. We saw that the upper quartile was 50, and our maximum value is 58. That gives us a box plot from a cumulative frequency curve. So what it's saying here now is that my middle 50% are fairly spread out. We can see now that there's quite a range now in these. Let's say I did another breed or another batch of worms, and it looks something like so. So let's go ahead and put this here. We might have a box plot that looks like this. Okay, and I'll put this just here. And we'll draw something up. When these box plots are put together and we can compare them, it's quite nice to see different values on here. So let's draw up. So this might be my second breeding session of the worms. So I fancied myself to be a bit of a worm expert. If I'm selling these, I want them to be as fat and juicy as possible. But the second ones now come up to be this. So what we've got here now on the second batch, which I've not drawn, is the following. So we can see now that the smallest value, this is the lower quartile, this is the median, this is the upper quartile, and this is the largest value. Straight off, we can see in batch number 2 of the worms that the smallest worm in total come from the second batch. The largest one here we can see is significantly lower than this one. We can see whilst these are more consistent, on average they're smaller, and we can see that by both the median and this interquartile range. In the video on box plots, I've kind of a bit off sort of schedule here. We will be looking at making comparisons in context with box plots. But this just gives us a really good visual representation that the second batch was more consistent. The middle 50% were closer together. We can see that they are going to be a lot smaller. So if you're trying to breed big worms, this would be hugely disappointing. So that's what we have. That's a cumulative frequency curve, and that's a cumulative frequency table. So all we're doing is adding them up. For an estimate for median, we find now the halfway up the observations. It's the 30th. We read across and we drop down and give an estimate. It's only an estimate as this is group data, and it only gives us an estimate because our estimate's only as good as our curve. The cumulative frequency will always be on the y-axis or vertical axis. Our groups are just here. We can find some information about measures of the central tendency, and also looking at the measures of the spread of the data. There will be another video on box plots, but hopefully that's given you a good introduction to cumulative frequency. I think before I do finish the video, we might be asked a question in the exam to estimate how many worms were going to be. Now let's pick a value. Let's say 40 millimeters or less. All we would do is simply now draw up and read across. So if we look at 40 or less, we could read up, and we could see that at this stage the cumulative frequency looked to be about 35 or 36. So we could say about, give or take, again, lots of room for estimate. 30, let's say it's 35. Let's just tidy that up. We could say that about 35 of the worms were going to be less than 40 millimeters. You might be asked another question. We want now the smallest 50 worms, and what roughly is going to be the maximum length of those. Well, we can now find 50. We can read across, drop this down, and we could say approximately, give or take, 54 millimeters. So there we go. I think that is about enough on cumulative frequency charts and cumulative frequency curves.